All right, we're going to continue with our reciprocal and rational graphs, but today what we're going to look at is what happens when the top doesn't have a 1. So all of our graphs we looked at in the last lesson were like 1 over x plus 2, or 1 over x squared plus 3x minus 4, or something like that. So those were reciprocal functions, which were a little bit easier because we just had a 1 on top. But like we did earlier in this unit, we kind of often have other things on the top besides a 1, which makes it a rational graph, which will actually change the graph quite a bit. In some cases, they're really complicated. Other cases, if things cancel out, the graph actually becomes quite a bit simpler. So if we look at this title page one, if our original equation was x plus 3 over x squared plus x minus 6, if we factor the bottom, we would get minus 2 and plus 3. We can see that our x plus 3 actually cancels out. So this graph actually would simplify down to just 1 over x minus 2. And we know from yesterday's lesson that our non-permissible would be 2, so that's going to be our asymptote line at 2. And we could calculate our invariant points where it's going to be 1 and negative 1. So in this case at 3, 1, and at 1, negative 1, those are invariant points, and we can just draw our curve from there. So what's weird is even though we started with a quadratic on the bottom, after we cancel we just get 1 over x minus 2. So if we graph the original, the one I got in the box there, the x plus 3 over x squared equation, and if we graph our final answer, they both actually give us the exact same graph. But what we're going to see today, there's one slight difference between the graphs that don't often show up. So we'll figure out what that is in today's lesson, and that's it for this unit. So we just saw on the last page, if I take the original graph and we factor it and cancel, we actually get a very simple graph. We just get our reciprocal of 1 over x minus 2. So let me go back to the title page again. So remember that was just our linear line, x minus 2 was something like that. And from there we could graph our reciprocal just like we did yesterday. So once we simplify, we can see we only get one asymptote line. We get an asymptote line at x equals 2. So because our graph 1 over x minus 2 is still like our ones we did yesterday, that's where our asymptote line. So our asymptote was still at x equals 2. The other thing is we see this canceled factor. We actually canceled out that x plus 3 in both terms. So that means x plus 3 is a non-permissible value. But if we go back to the graph, the x plus 3, if we look at this graph, 3 is right where I put that dot there. Right, it's at 3, 1, and it looks like it's on the graph, but we also know that because it's non-permissible, we have x can't equal 3. So what that means is if you look carefully on your graph, and your normal graphing calculator won't show this, but what it does, it'll give you an error if you go to your table. So what that means is we actually don't have a point at 3, 1. We actually get a little bit of a space in the graph. And we call that a point of discontinuity. So the graph is not continuous, it actually has a little bit of a hole there, and we draw it as kind of like drawing a little bullet hole. So what we want to basically remember then is with any kind of graph, the non-permissible that cancels, so in this case the x plus 3, that's going to be represented as a little open dot, and the other non-permissible that doesn't cancel, the plus 2 in this case, that'll be our asymptote line. And that's really the only thing you need to know for today's stuff is if you simplify these things, where is the asymptote line going to be and where is any points of discontinuity? Draw the simplified version of the graph using the same rules we did before, and that's it. So let's try a simpler example. So what you want to do in any of these cases is try to simplify. So if we factor the top, we take out a 2. We have 2 times x plus 2 over x plus 2. We can see here that that factor of x plus 2 would actually cancel. So our simplified graph is just y equals 2. Well, that's an easy graph to draw. Y equals 2 is just a horizontal line passing through the point 2. So that's easy, but we got to go back to look at our non-permissibles. We have a non-permissible of negative 2. So what does that mean? Well, at negative 2, because that factor canceled, that means at negative 2 we actually have a little space there. So our actual graph would be a little bullet hole like that. We simplify it to help us draw it, but then we just worry about our non-permissibles. We have nothing on the bottom. Our final answer was just 2, so we have no asymptote lines in this case, just that little bullet hole. And we can do our domain and range just like we did before. Our domain in this case is every real number except for where that non-permissible is, so that's -2. And our range in this case is pretty simple. We only get 2. Every point on the graph is just a line going through 2. And that's it for that one. So that's pretty easy. Let's try another one here that's a little bit different. And I actually messed up on this one. This should have been a 6x, not 2x. So let's change that before we start. So if we factor the top, we would get x plus 4 and x minus 2. If we factor the bottom, we get x plus 4 and x plus 2. So we can see our x plus 4's would cancel. So our simplified graph should be x minus 2 over x plus 2. So if we actually graph that one, and if you're not sure, you can follow the same steps we did before, or we can just actually graph it on your calculator and see. But let's review the old steps anyway. So our x plus 2, the one that's on the bottom, remember that'll be our asymptote line. So we'll have an asymptote at x equals -2. We can try to calculate our invariant points, but let's not worry about it. We know that we have x plus 4, so -4, so that's going to be our discontinuity. It's going to be when x is -4. We don't know where to draw that because we don't know the y-coordinate, but if we actually plug that into our simplified answer, our y-coordinate would be -4 minus 2 on the top. Let me fix that up a little bit. And we divide by -4 plus 2 on the bottom, so that would give us -6 over -2, which would simplify to 3. So that means our discontinuity is going to occur when x is -4 at a y of +3. So that's where our little bullet hole is going to be. Okay, and let's just try, if you want, we can just sort of see that our graph ends up being a little bit weird. And if you graph this on your calculator, instead of our horizontal asymptote being at along the x-axis, in this case it ends up being at a line at 1. And we don't need to worry about that. You'll learn about that in Math 30. But for now, just sort of realize, and if you look at your graph on your calculator, we can see we end up getting our graph looking something like that. And that's it. So there's our graph. We can kind of see where our bullet hole is. We can see where our asymptote lines are. And that's it. And that's really the only thing you need to understand from this stuff is the factor that cancels becomes your discontinuity point. The factor that remains on the bottom as your non-permissible becomes your asymptote line. So let's try one more. So in this case, if we factor the top, we have x plus 3. Factor the bottom, we have x minus 4 and x plus 2. So you can see in this case, nothing cancels. So we get 2 asymptote lines. So we have 2 asymptote lines in this case at 4 and -2. And because nothing cancels, we have no discontinuity points. So we're just going to get our regular graph of 4 and -2. So we'd have our vertical line at 4, another one at -2. Those are 2 asymptote lines. We could then, just like we did before, we could try to figure out where our horizontal and vertical, our invariant points are, or we can just use our calculator. So in this case, let's speed things up a bit and just use our calculator. So we would end up getting our graph kind of looking something like this. And that's it. So that's what our graph ends up looking like once we draw our graph. But once again, you just got to remember the key thing is your asymptote lines and the discontinuity. And that's all for this lesson.